Hi dear students, today we are going to discuss important types of numericals from Unit 1 Water Technology. If you see at the bottom of the slide, you can see question number 1 or question number 2. So here in same question paper, there will be 2 questions on first unit, and out of 2 questions, you have to solve either question number 1 or question number 2. Now it's up to you. If you select question number 1, then there will be one numerical compulsory for 3 marks, and if you select question number 2, then there will be 2 numericals on it and total weightage 6 marks. As you know, for passing in SEM examination, total 12 marks you required. So here, if you select question number 2, then your 50% work will over if you solve 2 numericals perfectly, because 2 numericals will give you 6 marks. So here, all 3 types of numericals we are going to discuss in simple way, along with their formula and calculation with some examples. So first type is hardness determination, and in that we are going to find total hardness, permanent hardness and temporary hardness. Second type is the alkalinity of water sample, and in that we are going to find types of alkalinities and after that its amount. Third type is the zeolite method, and in zeolite method you have to find liters of hard water softened or hardness of water. Out of 2, 1 you have to find out. Now one by one we are going to discuss. So first we will see that is what hardness of water sample. So dear students, for solving this numerical, formula is very simple, and same formula you are going to use for first one total hardness and for second one permanent hardness. Dear students, try to understand total hardness. Who will give you total hardness? Untreated water will give you total hardness. Untreated water means we have not done any kind of treatment on that water. As such water we are taking, so that untreated water containing both permanent as well as temporary hardness. So untreated water will give you total hardness, and formula for that is Y multiplied by M2 multiplied by 10 raised to power 5. In simple way, you have to remember 10 raised to power 5 divided by V. Now second, you can see boiled and filtered means first you are going to boil the water, then you are going to filter it. Means what you are doing? You are doing a treatment. You are giving treatment to the water. So after treatment, what will left behind in the water? Only permanent hardness will left behind in the water. So after boiling and filtration, permanent hardness will remain in water. So here again formula is same. Y is equal Y multiplied by M2 into 10 raised to power 5 divided by V. Now here Y is the burette reading, M2 is the molarity of EDTA, and V is the volume of water sample. So dear students, once you find total hardness and permanent hardness, it is very simple to find temporary hardness, because total, what is meant by total? Total is equal to temporary plus permanent. So for finding temporary, you have to subtract permanent hardness from total hardness. So you will get temporary hardness. And as far as unit is concerned, you can write either ppm CaCO3 equivalent or mg per liter. Okay, so formula clear? Two formulas are there. First formula common to total and permanent, and second formula, that is what total hardness is equal to temporary plus permanent. Now we will see the example so that you will get clear cut idea about it. Now see the question. 50 ml water sample means how much water sample is given to you? 50 ml. Okay, so that 50 ml required how much ml EDTA? 18 ml. Okay, what is the molarity of EDTA? 0.05. Okay, so that 50 ml water sample and 18 ml EDTA it means that 15 ml water is a untreated water, and that will give you total hardness. Now see the second part of numerical. 50 ml of same water sample, same 50 ml same water sample, but here what we are doing, we are boiling it, we are filtrating it, means we are giving treatment to the water. Now you can see the requirement of EDTA 9 ml, means requirement of EDTA decreases after boiling of water sample. What it means? It means less amount of EDTA required for titration, right? That is what, only permanent hardness is present in the water sample. That's why less EDTA is required, right? And if you see the beginning part of the numerical, in that 50 ml water sample is there, but how much ml EDTA consumed? 18 ml. Why 18 ml? Because that water sample contain both temporary as well as permanent, and that will give you total. And after boiling and filtration, you will get only permanent, right? So here you have to find total, permanent and temporary hardness. Now you have to write given while solving the numerical. So what is the first part of given? First part of given is phi is equal to 15 ml. EDTA, how much ml EDTA? 18 ml. What is the molarity? 0.05. Now here what you have to find? Total hardness. Now second part of numerical, that is what, part 2. Now sample is boiled, so phi is 50, ml of EDTA 9 ml, molarity M2, that is 0.05. So boiled sample will give you what? Permanent hardness. So given of part 1 will give you total, given of part 2 will give you permanent. So total minus permanent, you will get temporary. Okay, so unit for this one, ppm or milligram per liter. Now we will see the formula and actual calculation. So again on this slide I taken part 1, part 2 given. So formula is common, same for part 1 and part 2, that is y into m2 into 10 raised to power 5 divided by phi. So y for total 50, m2 for total hardness 0.05 multiply by 10 raised to 5, okay, and divide by phi. What is a phi? Phi is a 50 ml, okay. And here if you do the calculation by using a calci, you will get total hardness 1800 ppm. Now same formula you have to use for part 2. Now what will be the change? Only one change will be there, that is the value of y, that is what? Burette reading, and that burette reading is ml of EDTA, y is 9 ml. Only one change, y will become 9 ml. If you take 9 ml, then you will get permanent hardness 900. So temporary, total minus permanent, 1800 minus 900 will give you 900 is the value of temporary hardness. Now one numerical for you for practice, you can solve it, right? So here I directly given of the numerical. So likewise the way we solved numerical 1, sample phi 100 ml, ml of EDTA 13.8, molarity 0.01. So see here water sample 100, that is untreated. So this part will give you total hardness. Now see the second part of given, boiled and filtered. It means boiled and filtered will give you only permanent. So in second part you will get permanent. So the way we solved in numerical 1, same way you have to solve here. Part 1 will give you total, boiled and filtered will give you permanent. So total minus permanent, you will get temporary. Alright. Now we will proceed toward the second type of numerical, and that numerical is alkalinity of water sample. So here you have to find total, you have to find two things. One is the types of alkalinities and second its amount. So first we will go through the formulas that we need for calculation. So dear students, in alkalinity determination for titration we are using two indicators. For first part we use phenolphthalein indicator, that is a P indicator, and in second part we are going to use methyl orange indicator, that is M indicator. Now if you see this slide, if you see the formulae, there is only one change in first and second formula. What is that change? In phenolphthalein you have to take Phe1, and in methyl orange you have to take Phe2. In both the case Z same, 50 same, 1000 same, Phe same. So what is the difference that you have to remember, right? So phenolphthalein Phe1, methyl orange Phe2. Okay, now Phe1 and Phe2 are hot, burette readings. Phe is hot, volume of water sample, and Z is hot, Z is the normality of acid. Okay, so for solving a numerical, you should know the formulae. Okay, and formulae are very simple. Only difference in P phenolphthalein Phe1 is there, and in M methyl orange Phe2 is there. Now only these two formulas are not enough for solving the numerical on alkalinity of water sample. One most important table that you should know. If you know that table, then only it is possible to find types and the formulas that required to calculate its amount. So this table is very important and must to solve the numerical. So the time when you entered in the examination hall for INSEM examination, you will get answer sheets. The moment you get answer sheet, on the last page you just write rough work heading, and below that you just make this table before to get question paper, in order to utilize available time effectively, in order to reduce the time required to make this table during solving the numerical. So it's better to make this table immediately once you receive the answer sheet, because numerical will be there in your question paper, compulsory numerical will be there. So this table you required for solving the numerical. Now how to make this table in simple and easier way during examination? So dear students, first column you can see, or you can see second column. In that I mentioned relationship between P and M, or Phe1 and Phe2. Now why Phe1 or Phe2? Phe1 and Phe2 because P stand for Phe1. P stand for Phe1 bole to P will give you Phe1 and M will give you Phe2. So whatever relationship is there between P and M, same relationship will be there between Phe1 and Phe2. Now you will think that why this relationship is required, because once you able to find relationship, now how to find relationship? For finding a relationship, you should know the value of P and M. And just now in previous slide we have seen the formula for P and formula for M. So by using that two formulae, you will get values of P and M. Once you get that values, you just compare that two values with one another, and after comparing you able to find relationship. So first relationship you can see P is equal to 0. P is equal to 0, right, means Phe1 is equal to 0, and it means that for phenolphthalein end point, means by using a phenolphthalein indicator, right, you will not get pink color. If you add phenolphthalein, you will not get pink color. You are not getting a pink color, it means P is 0. Okay, so in that case you can see three columns, that is what alkalinity in ppm, OH minus, CO3 2 minus, HCO3 minus. So below OH minus dash, it means absent. CO3 2 minus below you can see dash, it means absent. And last one HCO3 minus, in green color I mentioned M. So HCO3 minus will be the type, only one type, and for finding a amount of that type you have to take value of M. Okay, so P is equal to 0, it means you will get only M. Okay, and M value you able to find by using the formula of m. And what is the formula of m? phi2 into n, that is what? Normality, or you can say z, multiply by 50 multiply by 1000 divided by phi. Now second relationship, P is equal to m, means how you will come to know that value of P is equal to value of m. Once you get values of P and m, you just compare it. If both values are same, it means you got relationship P is equal to m. That is what phi1 is equal to v2, right? It means that only one type of alkalinity is present, and that is what? OH minus. So below OH minus and in front of P is equal to m, you can see there is a formula of m. So m, that is what? M is equal to P. M is equal to P means value of P and value of m both are same. So only one type of alkalinity is present, that is the OH minus. Then third relationship, P is equal to 1/2 m, or phi1 is equal to 1/2 m. So here in front of that relation you can see only one type of alkalinity is present, that is what? The carbonate CO3 2 minus, and first one and last one both are absent. Now fourth relation, P is greater than 1/2 m. P is greater than 1/2 m. So what is the formula for that? You can see below OH minus 2P minus m, means OH minus is present. Then below CO3 2 minus, you can see the formula 2 inside the bracket m minus P, and last one is a dash. Dash indicate that type of alkalinity is absent. Okay, so here if you get relationship P is greater than 1/2 m, then two types of alkalinities are present. In that, one is OH minus and second is CO3 2 minus, and dash indicate alkalinity is absent. And for formula for finding OH minus, that is a 2P minus m, and you already got value of P and m. So put the value of P and m, right? Do the calculation, you will get amount of OH minus. Likewise for CO3 2 minus, what is the formula? 2 inside the bracket m minus P. Put the values of m and P, do the calculation, you will get amount of CO3 2 minus. And last relationship, P is less than 1/2 m. So here phi1 is less than 1/2 phi2. Below OH minus dash, it means absent. CO3 2 minus 2P is given, it means it present, and formula is 2P for calculation to find the amount. And CO3 minus, HCO3 minus, and formula is m minus 2P. It means HCO3 minus is present. Okay, so dear students, this table you have to draw, you have to make it in your answer sheet before to receive question paper. And for that you should know the relationships in a proper sequence. Okay, and what is that sequence? If sequence is correct, then whatever things are there, whatever formulas are there in front of that relationship, that will come right. Otherwise, if relationship sequence is wrong, then formulas, right, become wrong. So relationship P is equal to 0, P is equal to m, P is equal to 1/2 m, P greater than 1/2 m, P less than 1/2 m. In front of that you have to make 3 columns, OH minus, CO3 2 minus, HCO3 minus. These are the 3 types of alkalinities. Okay, dash indicate absent, and if some formula is there, it means that alkalinity is present. Okay, so once you know the sequence of relationship, that is a P equal to 0, P equal to m, P equal to 1/2 m, P greater than 1/2 m, P less than 1/2 m. Then in front of that make 3 columns and write 0 0 m. अभी यम आखिरी को गया था तो आपको यम से शुरुआत करना है. यम 0 0 0 यानी कि डैश. हाँ, सो फॉर फर्स्ट रिलेशनशिप P इज इक्वल टू 0 0 0 m, देन सेकंड m 0 0, देन 0 2p 0 0 2p 0. Okay, then fourth one 2p minus m, 2p minus m, right? And then next one you change the position of P and m. Okay, so it become 2 inside the bracket m minus p, and last one 0 2p m minus 2p. Okay, so this formula is must for solving the numerical. Now we will see the example to solve the numerical. Now see, 100 ml water sample consume 5.2 ml 0.02 normal HCl up to phenolphthalein endpoint. What it means? For phenolphthalein endpoint, how much ml HCl required? 5.2. And how much ml water sample is taken? 100 ml. Okay, now second part, 15.8 ml. 15.8 ml is what? HCl amount, right, required to get methyl orange endpoint. And what you have to find? Types and amount of alkalinity in water sample. So question is given in the question paper. For example, while solving it in the answer sheet, you are not going to write question. Directly you have to write given only. No need to write question. So write the given. Given from the beginning of the question. What is the beginning? 100 ml water sample. So water sample which is equal to V, which is equal to 100. So V value is 100. Okay. So P end point burette reading. You can see in the question V1 is equal to 5.2 ml. Normality is given 0.02 normal. Okay. And for M end point, how much ml acid required? 15.8 ml. So 15.8 ml is the value of V2. So now here you know V1, V2, V and Z. Now put that values in the formula. So first formula, phenolphthalein alkalinity P, you know formula V1 into Z into 50 into 1000 upon V. What is the value of V1? 5.2. What is the value of Z? 0.02. What is the value of V? 100. Do the calculation, you will get value of P. Likewise for methyl orange alkalinity, what is the formula? Only one change, V2. And what is the value of V2? 15.8. Remaining things are same. You will get value of M. Now, value of P and value of M in front of you. You just compare that to two values. 52 is the value of P. 158 is the value of M. So you have to see these two values and you have to find out the relationship between P and M. Now, what will be the relationship? If you see the values, then relationship is P is less than 1/2 M. P यानी कि value of P less than value of M. Okay, means M की value अगर आपने हाफ भी की तो भी P का वैल्यू जो है वो कम है. M का वैल्यू अगर आपने हाफ भी किया तो भी P का वैल्यू उससे कम आ रहा है, यानी कि रिलेशनशिप आ रहा है P लेस देन 1/2 M. ओके, सो ये रिलेशनशिप जब आया है P इज लेस देन 1/2 M, देन आपको क्या देखना है? जो टेबल है वो टेबल में आपको देखना है कि कौन सी अल्किलिनिटी प्रेजेंट है उसमें. सो आपको क्या मिला यहाँ पे? व्हाट यू गॉट? P less than 1/2 M. So in front of that you just see OH minus is a dash, it means absent. CO3 2 minus 2P present. Yes, CO3 minus M minus 2P present. So here we got answer. Once we got relationship, and that answer is types CO3 2 minus, that is a carbonate, and HCO3 minus, that is a bicarbonate. So here, by taking help of the relationship and by taking help of the table, you came to know that presence of carbonate and bicarbonate in the sample. Now, for finding a amount, in same table we have seen CO3 2 minus is equal to 2P. What is the value of P? 52. So if you do the calculation, you will get answer 104. And for bicarbonate, formula is there in the table we have seen just now. So bicarbonate is equal to M minus 2P. So put the value of M, put the value of P, multiply by 2, you will get amount of bicarbonate. Okay, dear students. So in this way, first your task is to find value of P and M, then find out relationship, then take that relationship, check in the table. Table will give you types of alkalinities. Then in front of that types, you will get formulae. So use that formulae for finding amount. Now one numerical for practice. Here water sample is 100 ml, P end point 4.3, normality 1 upon 50 n. It means simple calculation 1 divided by 50, that is what normality 0.02. Okay, and fourth given, methyl orange end point further required 8.3 ml acid from burette. Further means additional. How much ml required? 8.3. It means for finding value of Phe2, you have to consider 4.3 and 8.3 for finding a Phe2. Okay, so here again you have to find types and amount of alkalinities. So let us see the meaning of further. And most of the students used to do the mistake here, right? So P end point burette reading value is 4.3. So 4.3 is the value of Phe1. Now what about Phe2? Methyl orange end point further required. Further indicate initial amount 4.3 plus 8.3. 4.3 initial and further 8.3 means you have to add 4.3 in 8.3 and you will get value of Phe2. So please take care of further word. If there is a word in your numerical further, then you have to add Phe1 value in second value, then you will get Phe2. Okay, otherwise we have seen numerical 1 how to solve, right? Only in case of further you have to do the addition. Okay, so rest things same, that value of P you have to find, then value of M you have to find, then you will get relationship, then check in the table. In table you can get the idea about the types of alkalinities and their amount. Okay, so this is about second numerical. Now last type of numerical we are going to see, that is what the numerical on the zeolite method. And in zeolite you have to find either, मीन्स जियोलाइट मेथड में आपको या तो लीटर्स ऑफ हार्ड वाटर फाइंड आउट करना है या तो पानी का हार्डनेस फाइंड आउट करना है. यहाँ पे आपको 3 फॉर्मूले लगेंगे, कंपलसरी 3 फॉर्मूले लगेंगे. ये तीनों फॉर्मूले आपको याद में रखना ही पड़ेगा. विदाउट फॉर्मूली, राइट, नो वन कैन सॉल्व द न्यूमेरिकल. सो फर्स्ट फॉर्मूला, व्हाट इज द फर्स्ट फॉर्मूला? अमाउंट ऑफ NaCl in milligram. First you have to find amount of NaCl in milligram, and for that what things we required? We required gram of NaCl, we required liter of NaCl, multiply by 1000. Okay, so simple formula, amount of NaCl in milligram is equal to gram of NaCl multiply by liter of NaCl multiply by 1000. Do practice, writing practice for 3-4 times, right? You able to recall that formula properly in exam. Now second formula, amount of NaCl. See, in first one we found out amount of NaCl, and in second one also we are finding amount of NaCl, but there is a difference. In first one you found out amount of NaCl in milligram, and in second formula you are going to find amount of NaCl in terms of CaCO3 equivalent. So for this formula, second formula, answer of first formula you have to take multiply by 50 divide by 58.5. Okay, so first formula answer multiply by 50 divide by 58.5. Okay, what is the 50? 50 is the equivalent weight of CaCO3 and 58.5 is the equivalent weight of NaCl. Okay, now last formula, hardness of water is equal to amount of NaCl in terms of CaCO3 equivalent divided by liter of hard water. Okay, means for third formula you are going to use answer of second formula, and for second formula you are going to use answer of first formula. So all three formulas are interlinked. Answer of first formula you have to take in the second formula, answer of second formula you have to use in the third formula. Okay, now we will solve the numerical on zeolite method. Now see the question. Zeolite bed exhausted by softening of 4000 liter of water. Means 4000 liter of water we passed through zeolite bed. Okay, now here we used 10 liters. What we used? 10 liters of 15% NaCl for regeneration. Dear students, in zeolite method, in theory, we have seen that we use NaCl for regeneration. So how much liter of NaCl used for regeneration? 10 liter. And what about the gram of NaCl? It is given in the percentage. We have to convert that percentage into gram. So here what you have to find? Hardness of water. Now, as per the question, you have to write the given. So first given, percent NaCl is given. So that percentage is 15%. So for first formula, we required gram of NaCl. So 15% NaCl means 15 gram in 100. But we have to make a volume 1 liter 1000 ml. So 15 gram in 100 means 150 gram in 1000 ml. Okay. Liter of NaCl given 10 liter. Liter of water is given 4000 liter. And what you have to find? Hardness of water. So this is what the given that you are supposed going to write in the answer sheet. And once you write the given, you have to put the formula, and in formula you have to place the values. So here gram of NaCl 150, liter of NaCl 10, liter of hard water 4000, and you have to find hardness of water. So first formula, amount of NaCl in milligram, which is equal to how many gram of NaCl? 150. Liter of NaCl 10 multiply by 1000. So here you will get amount of NaCl. Now second formula, in terms of CaCO3, the answer we got in first formula, that answer multiply by 50 divided by 58.5, you will get amount of NaCl in terms of CaCO3 equivalent. Now take that answer for finding the value of third formula. So take the answer of second formula, put in the third formula, that is what the hardness of water, that is our area of interest that we have to find. So hardness of water is equal to the answer of second formula divided by liters of hard water given, that is a 4000, you will get answer 320 ppm. Okay, so here if you know three formulae, only you have to put the values, formula based numerical is there, you will get correct answer, that is our hardness of water. One more numerical for practice you have to do, you have to solve by your own. Now see the given 20% NaCl, the way we seen in case of 15% NaCl. Now 20% NaCl means what? 200 gram of NaCl. Liter of NaCl given, how much? 50. Okay, now here you have to find liter of water, and hardness is given to you 350. Then use first formula, you will get milligram of NaCl. Use second formula, you will get NaCl in terms of CaCO3 equivalent. And third formula, now here hardness is given, you have to find liter of hard water. So rearrange that formula, and that formula in front of you, liter of hard water is equal to amount of NaCl in terms of CaCO3 equivalent. That answer you will get in second formula divided by hardness of water, that is what? 350. Okay, so once you put the value of 350, you will get value of liter of hard water. So dear students, this is about the three numericals, and that all three numericals will come in the INSEM examination. It's up to you to select question number 1 or question number 2. Okay, so if you select question number 1, mostly first numerical will be there, and in question number 2, alkalinity and zeolite, right? Two numericals will be there. So it's up to you to select question number 1 or question number 2, right? If you select 2, you will get 6 marks. If you select question 1, you will get 3 marks. So dear students, please see these all three types of numerical properly, definitely you able to score minimum 6 marks for numerical only. Okay, thank you for watching.